Diayevakarja. Hello everyone and welcome back. We're almost finished with our Type 4 engine inspection, repairs and upgrades. By the end of this video, I'm confident we'll have something that looks exactly like this. Firstly though, let's marvel at the glory of vapor blasting. This process has left the engine's aluminium castings more resistant to corrosion and even better than new. All of these items were originally factory painted in gloss black, a finish we saw in the previous videos had long since disappeared. This new powder coat finish is more resilient than traditional wet paint, meaning these items will be preserved for many decades to come. And of course, we have all the ancillary items, which I had re-zinc plated and passivated. As always, maintaining the originality of this half-century-old engine is my primary focus. Some items bear the scars of a long life, and that's okay too. They're all part of the story. Finally, we'll be reusing just about all of the original natural rubber seals. I put these items into a bag of silicone oil 2 weeks earlier, which they've soaked up and are now nicely softened and rejuvenated. Let's get to it. The first item's on. The Crossmember rubber mounts, torqued just like the previous video. Then the Crossmember itself, mounted to the same torque spec. Followed eventually by the fan shroud. Fitting this item gives an immediate sense of progress and is always good for morale. I rebuilt the alternator in part 2 of this series. The key to fitting one of these is to stick any old M8 bolt into the bottom mount to take the weight while you fiddle around with the rest of it. This engine came from the factory with a bead of sealant around the alternator shroud, so I'll put that back as I found it. The key to tidy sealant application is to firstly mask off where you don't want any glue to go. Then dip your finger in some dishwashing liquid and it'll allow you to form the sealant while it's still soft. Remove the tape as soon as you're finished. The heat exchangers are an integral part of the exhaust system. They are essentially a metal ducting around the exhaust pipe that collects heat for the vehicle warm air system. They're sort of high temperature recycling gadgets. These are the original factory fitted ones. They've had a few repairs over the years, but that's because replacements are expensive and I'd rather spend my money on lemonade. The units sealed to the cylinder head with a copper crush washer. Out with the old, in with the new. I make these videos all by myself. This is one of those occasions when an extra pair of hands would be useful. We're finished on the left underside of the engine. We just need a look at the thermostat on the right underside and we'll be finished there too. The thermostat is an expanding concertina that elongates when warmed by engine heat. This cable had a temporary repair about a decade ago, so this is a good time to replace it. As the thermostat expands and contracts, the cable operates a flap door that increases and decreases cooling air from the fan. Here's another use for a crimped electrical terminal. Looks like we're finally finished with the engine stand. And as if by magic, the engine is back on the buggy again. With the cooling fan fitted and the engine cold, the valve clearances for each cylinder can be set. I've painted a little white mark on the timing notch of the fan belt pulley and rotated it to 0 degrees on the timing scale, which also corresponds with the firing position for the number 1 cylinder. That's the little notch on the distributor body that the rotor arm is pointing to. I know that the number 1 cylinder must now be at top dead center, meaning both intake and exhaust valves are closed. I can double check this if there is free play in the corresponding rockers. For this European spec engine, the adjustment is 0.15 of a millimeter for the inlet and 0.2 for the exhaust valve. With the gap set, I tighten the locking nut with a spanner, not my fingers, then recheck everything. I turn the engine until the rotor arm moves 90 degrees anti-clockwise to the firing position for the number 2 cylinder and repeat the same process, then another 90 degrees anti-clockwise for the number 3 cylinder and repeat the process, and the very same for number 4. With the valve clearances set and rechecked several times, we can finally replace the rocker covers. I had the exterior of these covers powder coated, but not the interior. I wasn't sure just how heat and oil would react with the plastic coating, so I've opted to just clean and oil the insides of these. I'm putting a thin bead of sealing compound on the cover side of the gasket only. The gasket is made from cork, yet another example of renewable, natural, more environmentally friendly materials used on older vehicles. I've placed some insulating or electrical tape and a bead of lithium grease on the outside of the cover to help protect the finish during fitting. It's a trick that can be used in a few locations on these vehicles. We last saw builder number 700 in part 2. Well, I had to put 700 back in place for the next 5 decades. I don't know why my tinware has one novelty jumbo oversized screw, but I put that back in place too. These items have been painted in the correct L249 Dove Grey. The inlet manifold nuts are torqued incrementally to get a nice even seal around the crush gasket. I'm not sure if anyone will notice the freshly zinc-plated brake servo pipe bracket, but you may as well be hung for a sheep as hung for a lamb. With the preheater duct fitted, the fuel pump to carburetor hose can be connected. The union with the large input arrow is the feed from the fuel tank. We'll connect that up later. On the subject of fuel, we better take a look at the carburetors. These look like a twin carburetor setup, but the system actually operates more like a single carburetor that's been split into 2 halves. The left-hand unit is much larger and carries out certain functions for both. You could say that one half of this couple is working much harder at it than the other, which can sometimes be the case with relationships. We saw in part 1 of this series the high idling issue I've been having for some time. I'd always suspected that one or both of the automatic chokes may have been the cause of this. These chokes are just a spring that is heated by a 12-volt current, which in turn bends and moves the choke lever. The springs get saggy with age. Can't blame them, but I'm hoping these 2 new chokes will help solve this problem. My method for servicing carburetors is always the same. A full strip, thorough clean, inside and out, blow through with compressed air and reassemble with new seals and factory settings. The new chokes are calibrated by just lining up a mark on the choke body with one on the carburetor and tightening the clamp. And yes, I even had the original air filter housing clips repassivated. Oh yes, I went there. The final items for us to look at are all on the flywheel side of the engine. Starting with the pilot bearing. This bearing engages the rearmost end of the gearbox main shaft. This is of course a clutch alignment tool, but it's designed to mimic the shaft exactly. The bearing cannot be drifted out as it rests in a sort of blind alley, hence the name, a blind bearing. To remove this, I'll use a blind bearing puller. This was the point I realised the blind bearing puller plan wasn't going to work as I intended. And yet again, the grinder was called for. With the bearing removed, we can see how these tools work, expanding to grip the races from behind. We saw in part 2 how the flywheel and clutch surfaces were contaminated with engine oil. I had a local machine shop skim the surface of the flywheel to remove any unevenness that may have developed over the previous decades. This should ensure a smooth clutch engagement when moving off. The rear of these flywheels have an O-ring that is easily missed. The replacement is also made of Viton, which I sourced locally. This is the original clutch we removed in part 2, but my local machine shop installed a new set of friction plates. As always, recycling as much of the vehicle as possible and operating on the principle of a restoration by repair, not replacement, eliminating waste and maintaining originality. Imagine my surprise when I realised the Yamaha clutch mushroom was a perfect size for fitting the new pilot bearing. The 5 flywheel mounting bolts are self-locking and achieve this by distorting a soft metal disc which they bite into when tightened. This disc should be replaced each time the flywheel is fitted. We can see the old one still has the factory markings. And here we are, a practically brand new old engine, ready to be refitted. Please join me next time to see if all the work we carried out actually works. Until then, slán go fóill.